In the Swedish part of the Baltic Sea, about 5 kilometres offshore from the peaceful city of Karehamn, E.ON placed an order for the construction of a wind farm consisting of 16 wind turbines of 3 megawatts each. The contract for the design, construction and installation of the 16 concrete foundations was awarded to Jan De Nul in 2011 because of its capability in both concrete construction and marine installation works. Jan De Nul was responsible for the design of these foundations based on loads provided by the client. Because of the soil conditions, using piles was not possible. Therefore, it was decided to secure the concrete foundation on the seabed by placing extra ballasting. As the water depths range from 8 to 21 metres, the height of the cylindrical part had to be constantly adapted, and every foundation received its own specific design. By using a 10,000 and 23,000 ton barge from Jan De Nul's fleet, the foundations were constructed on the barge and lifted from the deck of the barges during the installation offshore. In a first phase, the half-metre thick base plate was reinforced and cast in concrete. As soon as the foundation base plate was finished, the inner and outer walls, the tower and the ice cone were cast. The reinforcement bars were anchored to each other at every crossing point, which was a complex and time-consuming necessity. By means of 4 tower cranes and 60 skilled workers, these foundations were finished within 4 months. This construction work required in total 10,000 cubic metres of concrete and 4 million kilograms of steel. The inside harbour of Zeebrugge was chosen as the construction site. There, behind the lock gates, the barges were not subjected to the effect of changing tides. Once the foundations were constructed, the barges carrying approximately 7,000 and 22,000 tons respectively travelled to Sweden. Each barge was towed by a powerful 10,000 horsepower tugboat over a distance of 1,500 kilometres. The seabed had been prepared before installation of the foundations. First, half a metre of the seabed was removed, using Jan De Nul's multi-purpose barge DN109. For deeper locations, the remotely operated underwater excavator Starfish was used. In order to provide an even cushion layer for the foundations, a gravel layer was installed, using a heavy-duty excavator on the pontoon DN109. In order to level the cushion layer, a levelling system has been developed by means of a levelling beam installed on the cutter suction dredger Vesalius. This allowed for levelling the gravel bed foundation bed within the design tolerances of plus or minus 45 millimetres. Once the gravel bed was installed and levelled, the heavy lift vessel Rambis lifted the foundations off the barges and installed the foundation to within 30 centimetres of the theoretical position by using its anchoring system and within a 0.25 degree inclination. After the foundations had been installed, they were ballasted so they could withstand the extreme forces of the sea and carry the actual wind turbine. In the primary phase of ballasting, the shaft of the foundation was filled with magna-dense crushed iron ore, which was placed via a funnel by means of a cable crane. In the next phase, the other compartments were filled with crushed iron ore. And finally, a layer of heavy quarry stone was placed as a top capping layer in order to provide protection against wave-induced seabed currents. In order to be able to complete the works before the start of the ice season, the caissons were filled by the large DP2 vessel Simon Stevin. This vessel successfully placed filter and armour rock up to 130 kilograms in an accurate way in the ballast caissons by means of its inclined fall pipe and with positioning in DP2 mode. In case of blow-on conditions, the allowable weather conditions were reduced in order to provide safe execution at all times. To prevent the gravel layer from being washed away, an anti-scour quarry stone layer was installed around the foundations. The wind turbine generators which were installed on the foundations were Vestas V112 with a rotor diameter of 112 metres and a production of 3 megawatts. Once the wind farm is fully operational, it will provide green power for 50,000 families.